electrical power to our household from the main supply, from the generating stations, over the transmission and distribution lines, and finally to socket outlets and light bulbs. Ideally, the power line voltages and currents resemble sinusoidal waveforms. However, due to harmonics, the waveform can be distorted. If we need to observe the power line waveform in such cases, we can use the oscilloscope. Voltage of main supply is 230 volts. The question is, can we connect such a high voltage directly to the oscilloscope? Yes. However, we need to carry out certain steps to work with higher voltages. In this video, we are going to learn how to observe power line signals. Don't forget that working with main supply is hazardous. So, if you are a beginner, please seek help from a competent person.
Safety first.
In this oscilloscope, the highest scale of volts per division is 5 volts. That means the screen can show only up to a maximum of 20 volts. If the input is higher than that, we must use the probe attenuation. Now, the input is attenuated 10 times with a high impedance. Look at the maximum voltage allowed for this oscilloscope. It's 300 volts RMS or 400 volts peak. So, it's safe to connect 230 volts main supply. As usual, we connect the probe to the calibration signal. You can see the square wave on screen. However, the edge of the square wave is not perfect. This is due to the input capacitance of the oscilloscope. To fix this, we need to carry out the process called probe compensation. You can see a small screw head in the connector of the probe. Using this adjustment tool, we try to bring the exact square wave. Undercompensated, overcompensated, rightly compensated. If you look at the voltage level, you can note that the voltage reading is 10 times lower than the real value. That is due to the attenuation. Don't forget that during the experiment, we need to multiply the voltage reading by 10 times always. One more thing. Look at the number of vertical divisions above the x-axis. 4 divisions. So, even if we select the highest scale, 5 volts per division, the maximum reading would be 200 volts. That means we can't observe 230 volts. As a solution, we can use the vertical variable knob to rescale the axis. Since we know the voltage level of the calibration signal, we can turn the knob until the waveform is displayed within a desired number of divisions. Let's bring it from 2 division to 1 division. That's 2 times reduction. With this new scale reduction, we must multiply the reading by 2.
Now, the scales are all set. I think you remember when observing a signal, we need to connect the oscilloscope ground as a reference point.
The ground connection of the oscilloscope is connected to its middle housing and the protective conductor of the socket. That means if we connect any point in the circuit to the oscilloscope ground, the circuit identifies it as a leakage to earth electrode through the protective conductor. As a safety measure, the protective device RCCB or ELCB will trip off the circuit. Before connecting any power line to oscilloscope inputs, we must ensure that the power supply to the oscilloscope is isolated from the main supply. Otherwise, the protective conductor should be disconnected from the socket. Now, we connect the power line signal to channel 1. Usually, we select same channel as the trigger source. Since we observe power line signals, we can use line as the trigger source. Now, the oscilloscope uses the frequency of the power line for triggering. Now, we can see the waveform. Let's connect another waveform to channel 2. You can see the two waveforms. Did you notice that the traces are displayed alternatively? It is difficult to observe them together. In this kind of situation, we can select the chop mode instead of alternate mode.
When we work with low frequencies below 100 Hz, chop mode is suitable. Do you know what scenario this is? The oscilloscope sweeps the traces of channels one after the other. At higher frequencies, sweep takes a very short time. As a result, the trace remains illuminated during the sweep of the other channel. At lower frequencies, the sweep takes a longer time. So, one sweep is erased during the sweep of the next channel. In chop mode, the trace selects each channel in quick intervals during a single sweep. In other words, it is like chopping the signals and combining them to form one trace. In this video, we have learned how to observe power line signals. Also learn the operation of alternate and chop modes. Our next video will show you some exciting features of trigger control. Please follow us.